Bom dia a todos. Agradeço a presença nesse evento que está sendo promovido pelo Energy Hub, em parceria com a Enterprise Singapore. Nós temos o prazer de trazer para vocês um pouco do que é esse ecossistema super vibrante de Singapura, que tem sido o que mais cresce nos últimos anos. É uma oportunidade única de estarmos juntos aqui, ouvindo um pouquinho sobre esse ambiente e conhecendo 3 startups super interessantes que com certeza vão trazer ideias e soluções muito novas aqui para todos nossos ouvintes conhecerem um pouquinho mais do potencial que temos aqui em Singapura. So we would like to thank you very much to all to Enterprise Singapore, to BeeX, Sun Green and Green Corp for being here today with us to give this opportunity to Brazilian companies to know a little bit about Singapore ecosystem. Thank you very much. I will give the word now to Audrey from Singapore Enterprise for you to better understand what we are proposing today. Thank you.
Bom dia, Ana, e ao Energy Hub, aos nossos amigos do Brasil e empresas de Singapura. Agradecemos ao Energy Hub por organizar a sessão de hoje, onde esperamos que vocês conheçam um pouco melhor nossas empresas de tecnologia de Singapura no setor de transição e energia. Sou Audrey Stan, diretora regional para a América do Sul da Enterprise Singapore, sediada em São Paulo. Hoje, estou aqui com meu colega, Julian Fruchá, gerente de desenvolvimento de negócios responsável pelo setor de energia. Gostaria de compartilhar brevemente sobre a Enterprise Singapore e o trabalho realizado pelo nosso escritório em São Paulo. A Enterprise Singapore é uma agência econômica subordinada ao Ministério do Comércio e Indústria de Singapura. Nossa missão é promover intercâmbios e interesses econômicos entre o Brasil e Singapura, nos níveis B2B e G2B. Também atendemos o restante da América do Sul a partir do nosso escritório, exceto a Colômbia, que está subordinada ao nosso escritório no México. Especificamente no setor de transição e energia, liderado pelo meu colega Julian, nossas empresas de Singapura estão interessadas em engajar parceiros brasileiros em esforços conjuntos nessa área. Acreditamos que a descarbonização é um esforço global e esperamos incentivar colaborações internacionais nesse setor. Isso abrange uma ampla gama de tecnologias de energia verde, como hidrogênio verde, biocombustíveis e outras tecnologias de descarbonização. Estamos abertos a colaborar com empresas brasileiras em soluções complementares pelos mercados do Brasil e da América do Sul. Nossas empresas de Singapura têm ampla presença global na Ásia, Europa e América do Norte. Esperamos que elas também tenham a oportunidade de participar dos esforços do Brasil nessa área, por meio de parcerias com empresas brasileiras. Sem mais delongas, gostaria de agradecer mais uma vez ao nosso gentil anfitrião, Energy Hub, pela oportunidade de hoje para as nossas 3 empresas de Singapura, BeeX, Sun Green H2 e Green Corp, compartilharem sua expertise e aos nossos amigos brasileiros por participarem do webinar de hoje. Esperamos que este seja um bom começo para potenciais parcerias. On behalf of Enterprise Singapore, I would like to thank our Singapore companies, BeeX, Sun Green H2, and Green Corp for participating in today's session. Thank you. Muito obrigada.
Bon dia. Hi, everyone. So I'm Julian, and I'll be the moderator of this webinar today. So just before we start with our first startup, BeeX, just a quick reminder, after each presentation, we will open the floor for a few questions from the audience. So please feel free to send your question in the chat box, and we will read them out. Okay, Grace, the stage is all yours, please.
Hello, everybody. Can you all hear me? Great. So good afternoon, evening, wherever you may be. My name is Grace. I'm the co-founder and CEO of BeeX. BeeX is a spin-off from the National University of Singapore, where we design, manufacture, and operate autonomous underwater vehicles to carry out large-scale inspections of underwater infrastructure. Over here, you are looking at our flagship vehicle being deployed to inspect a German wind farm, which we have been doing for the past 2 years now. And I will go a little bit into detail about exactly what we do. BeeX was started essentially to disrupt the underwater inspection market, as we see that due to the large amount of underwater data requirements, the cost of acquiring such data has been increasing. This has been driven due to various increases of demand from infrastructure and renewable projects, which is now competing for the same resources that previously was being used exclusively only for oil and gas projects. What BeeX does is to then essentially reduce the reliance on large vessels, where typically it was previously done with a large underwater vehicle and a large vessel to conduct operations. By transferring all the intelligence into the vehicle itself, we are allowing the vehicle to operate independently of these support infrastructure like vessels that hence drive down the cost, the operational risk, and also the CO2 emissions from such projects. BeeX delivers a fully integrated solution end-to-end. We are one of the few service providers that actually design and build our own systems, and this is our core IP with manufacturing intelligent vehicles that have been acquiring 14 years of underwater data from 3 different parts of the world to help the vehicle learn and think and operate without human intervention. Our vehicles are now known to be one of the most compact form factor in the market, which allows us to carry out fast mobilization throughout different projects. We have 6 of these vehicles now operating in different parts of the world, generally in Asia and in Europe. And our teams offer real-time measurement capabilities with the sensors that we have on board the vehicles. And we also offer near real-time cloud-based reporting using additional AI algorithms that allow us to classify the inspection data to reduce the amount of time that it takes for the client to make a decision on their assets. Today, we have 2 vehicle models. We have 6 of the smaller ones and 1 of the bigger one. We generally recommend different customers what they should be using based on their environmental conditions that are being experienced and also the scope of work that's being required on site. Generally, with the smaller vehicle A Ecambilis, it's already able to do projects that typically was using vehicles that are 6 to 8 times larger. And we are able to streamline this because of our in-house manufacturing and design capabilities. The vehicle looks like this for operational project. It has a bespoke computing system inside that we design to allow for fast compute and processing of multiple underwater data streams. And it fuses underwater positioning to allow us to understand where the vehicle has been. I have a short video to show exactly what the vehicle sees when conducting an underwater inspection. And today, we have tested the vehicle across multiple project sites to demonstrate the operational capabilities in different environmental conditions. The deployment has also been validated to be fully independent of vessels. So 3 main points. The whole entire operations is mobile. We are able to get to any location within 3 days of requirement, and we are able to then mobilize the equipment onto the structure with just 2 lifting bags. The mobilization process is also fast and simple. It takes us about 30 minutes to transfer our equipment from the vessel of opportunity directly onto the structure. And we have also validated our launch and recovery mechanisms, launching from the available infrastructure on site or with a portable crane system. This is how the launch and recovery looks like. So we typically will use the on-site crane directly. And on an operational wind farm, some of the infrastructure is already set up for us to launch. The vehicle essentially gets launched from that crane, and once it touches water, it will then detect that it's supposed to station keep at the last known location and carry out the inspection. This allows us to make sure that despite the harsh environmental conditions, we are still able to conduct the job. So once the vehicle is underwater, instead of the conventional approach where you only see a camera footage, we actually also fuse in our underwater positioning system with acoustic sensors that we are using to make a better decision to carry out the underwater inspection. So over here, this mission of inspecting a cable protection system is actually done fully autonomously with the vehicle, making the decision of what to do, what to inspect, and changing its path when it sees an anomaly. So for example, at the end of the cable, the vehicle will make a decision to turn back and inspect the other side of the cable, and it will know exactly when it should stop and when it should continue its inspection. Today, BeeX is one of the only few companies that have been able to demonstrate ultra low altitude bottom tracking. So we are able to stay very close to the seabed when conducting our inspections. And our inspections have been validated by 3 of the top 5 offshore wind farm developers to be able to conduct operations without human intervention. So this really unlocks new capabilities because the infrastructure and the resources required to support these inspections are greatly reduced. We are seeing asset owners benefit from at least 40 to 60% of cost savings when using these methodologies to conduct inspections. So these inspections can also be replicated to other type of structures. While we have inspected mostly POW structures when we started, so we have 1,000 POW-link structures in our data repository, where we have been working with the top few energy operators like Shell, ExxonMobil, Chevron. We are also looking to partner with more developers, more energy operators to inspect their nearshore infrastructure at a much faster rate compared to before. So we have thousands of POWs to demonstrate the intelligence and generalization of our autonomy. But you can also use that to inspect other kind of objects on the seabed, such as anchor POWs and floating infrastructure. So what we are seeing is that the autonomy within our vehicles are generalizing. We are now able to inspect more and more types of infrastructure. The first time that we launched the product to market, it took us about 6 months to demonstrate the autonomy. We are able to cut down that time to less than 3 months for us to carry out the learning. Thank you for listening to my presentation. Please let me know if you have any questions.
For this very insightful presentation, we will open the floor for questions. Se alguém tiver alguma dúvida, pergunta para a Grace, para a BeeX sobre as soluções, podem enviar no chat do YouTube. Maybe one first question, Grace. We have in Brazil deep and very ultra deep waters. So what is the maximum depth for your solutions?
Yeah. So currently, BeeX, we only focus on water depths of up to 300 meters. So we are not investing into deep water systems, primarily because we see that, firstly, the deep water problem is a mechanical one rather than a software one. So it is very likely that we will collaborate with a mechanical partner that has the vehicle, and we transfer our software brain into the mechanical systems instead.
Okay, thank you so much. Okay, I don't see any more questions. I guess the presentation was quite clear. Thank you so much, Grace.
Thank you.
Thank you so much. I will now ask Tulika from Sungreen H2 to share her screen. Perfect, we see you. Off you go, Tulika, please.
Thank you, Julian. Good morning, everyone. Nice to be here. I'm Tulika Raj, CEO and co-founder of Sungreen H2. At Sungreen H2, we are in the business of making the production of green hydrogen as cheap as possible. Let me present a brief introduction video to explain how. Everything that can be electrified must be electrified. When you cannot use renewable electrons, which are now cheap, that is the time to turn to green hydrogen. My name is Tulika Raj, and I'm co-founder and CEO of Sungreen H2. Green hydrogen production from electrolysis has been around for over 100 years, but it takes a lot of energy and expensive materials like platinum and iridium. So what we have is a nanostructured electrode using no precious metals. These electrodes have been carefully engineered using nanotechnology in order to double the surface area available for the water splitting reaction and reduce the energy consumed in the process by 10 to 20%. The technology is under patenting. We think this is a scalable and sustainable way for the industry to realize the hundreds of gigawatts of growth coming for it.
Powering tomorrow in association with IRENA.
Thank you for your attention. I would now like to present some slides about the technology, and I look forward to taking any questions from the audience later. So Sungreen H2 supercharges electrolyzers with advanced materials-based components. This allows us to produce more hydrogen from the same electrolyzer using less energy and no precious metals. This is how we are reducing the capex as well as the opex of electrolyzers to unlock the cheapest, most affordable green hydrogen molecule. The company is founded in Singapore in 2021 and rapidly commercializing a growing portfolio of products, including plug-and-play electrolyzer systems, electrolyzer stacks, as well as electrode components for all types of electrolyzers. We have notable deployments in 6 countries globally, are scaling with over 10 marquee name customers. We have multiple strong partnerships signed internationally, and a few examples are shown here on the bottom right-hand side of the slide. We are institutional VC backed and have a strong team with very capable advisors who have been leaders in the energy transition space. Sungreen H2 is in the business of manufacturing and supplying electrodes and stacks, which can be provided as plug-and-play integrated electrolyzer systems for any type of applications spanning from industrial to mobility to long-duration energy storage. In all cases, the turn-up ratio of the electrolyzers is 200%, which means that the electrolyzer, if it has a rated capacity of 1 megawatt and a cost of $800 per kilowatt, you can run it at 2 megawatts, bringing down your per kilowatt capex cost to $400 per kilowatt. And the energy efficiency is ranging between 80 till 90%, one of the world's highest. We don't use any precious metals, which means that the technology is both scalable and affordable, and it is ultra stable. The degradation of the electrolyzer stacks is less than 1% over 1 year, which means that when provided into an electrolyzer project, the 25-year project lifespan will require only 2 stack changes, in line with the current industry leading technologies. SunGreen H2's proprietary technology really spans with using advanced nanomaterials. We are solving the problem of efficiency, durability, and cost, which is the current conundrum in the electrolyzer industry and poses a trilemma. With the Nano 4X electrodes that never die, we are solving this problem for all electrolyzers, and in particular, we don't use any chemical or polymer binders, allowing very easy, non-toxic handling of the materials for the electrolyzer manufacturing, a massive surface area for the electrolyzer process, and we only use nickel-based earth-abundant nanomaterials. With the 10 years lifespan or very low degradation, the doubled current density versus what's available in the market, all of this without using precious metals, and at average of 85% HHV efficiency, we are providing a solution that meets the need for industrial scale manufacturing and rollout of electrolyzers. You can see here that our platform technology is capable of manufacturing industrial size electrodes. We are exceeding the targets set by the industry and the US Department of Energy for performance, and have showcased and validated the technology with multiple real-life field runs, but also with Fraunhofer, Germany-based testing lab, as well as A-Star testing lab in Singapore. The technology that SunGreen H2 provides offers critical scale-up advantages for all electrolyzers, regardless of the type of technology, either by supplying directly the electrodes or completely supplying the stacks produced on our assembly line. We are able to provide a final solution in the form of our products that can span both the electrolyzer OEM space as well as the hydrogen production space. Key clients for our electrolyzer stacks and completed systems are, of course, hydrogen producers. But we also have a good line of business supplying electrodes for better performance of alkaline and PEM electrolyzers. Both key product lines, electrodes and stacks, are manufactured in-house, and integrated systems are provided with our partners for plug-and-play solution to produce hydrogen at record energy efficiency of 45 kilowatt hours per kg or 88% HHV in the field at low temperatures. The electrolyzer operates at 70 degrees Celsius and has already been proven as a disruptive technology for both advantages in cost and efficiency, but also for its great flexibility and rapid response to intermittent renewable energies. Currently, we are supplying stacks in 3 sizes, 2, 20, and 40 kilowatts. Next, the company is coming to the market with 200 and 400 kilowatt stack sizes, the world's largest, most efficient for electrolysis. Here are some technical statistics that can be shared separately should there be interest from the audience in learning about our modular solutions, which go all the way up to megawatt scale. If I were to put it briefly, then compared with the best available high-efficiency electrolyzers in the market today, SunGreen H2's technology offers a further 30 to 40% cost saving, closing the gap, the cost gap with gray or blue hydrogen at $2 to $3 per kg levelized cost of hydrogen production, with capex that is under $1,000 per kilowatt for a high-efficiency 85 to 90% efficient system. And this is assuming 5 cents electricity pricing, which in Brazil can be lower still. Don't take our word for it. The multiple electrolyzer deployment and demonstrations that we have carried out showcase the technology working very well in real-life conditions in all sorts of use cases with multiple partners spanning use cases like industry, power to X, methanation, gas blending, and transport use cases for hydrogen. We are serving a global electrolyzer market from our base in Singapore. And here you can see where our technology is being deployed globally by industry leaders in various fields for various applications, including megawatt scale systems being delivered as of 2025. Here, a very good example of the work that we have done with our industrial partners, Naturgy, in deploying electrolyzer at a green biorefinery project, and now a second size of electrolyzer currently shipping out. Similarly, working with PLN, Indonesia's state-owned power utility, for power-to-X application, supplying a modular electrolyzer in Indonesia for gas blending. The technology has been tested, as I mentioned, in a number of different use cases, with the efficiency being tested not only at CSIRO in Australia, but also in Germany. We have an award-winning team commercializing a breakthrough technology to bring down the cost of green hydrogen and plug the gap with gray and blue. Having received a number of awards, we look forward to interest from the audience to connect and bring SunGreen H2 electrolyzer technology into Brazil-based project, be it green steel, green cement, other industrial applications, mobility, or long-duration energy storage. Thank you.
Thank you so much, Tulika, for your presentation. Very interesting to learn about your ultra-efficient electrolyzers. I think it's very interesting for the Brazilian markets. We will have a few moments for question. Maybe a first question, Tulika. Beyond efficiency, can you share more about the durability of your electrolyzers?
Yes, thank you. Julian, one of the key ways in which electrolyzers are being run today is by pairing them with renewable electricity. But as we know, renewable electricity is intermittent. It is a very on-off operation. Most electrolyzers that are commercially available suffer degradation effect when you are running the electrolyzer in this kind of intermittent fashion. However, one of the key advantages of SunGreen H2's technology, due to the nano engineering that we do, there is virtually no degradation. And so the materials can survive very harsh operation in on-off mode, maintaining the lifespan of 10 years. We expect this lifespan to be longer, and we are looking to prove this out in multiple projects. What we can say is that so far the testing that has been done has catered for this kind of on-off operation and shown less than 1% degradation over 1 year, allowing for a 10-year stacked lifespan. And this is purely down to the engineering that the company provides.
Okay, thank you so much. What about the adaptability of your electrolyzers to different renewable energies?
Highly adaptable, very wide dynamic operating range, regardless of whether it is hydro, geothermal, solar, or wind. The electrolyzer can take any kind of variable load. And in fact, in our project in Indonesia, it's being connected, the electrolyzer directly to solar PV without any batteries in between. As you know, this brings down the cost of the overall project. It also avoids DC-DC conversion losses, so it's a very efficient overall project. But most importantly, very few electrolyzers can do this kind of adaptable operation because the degradation starts to rise. But in our case, this is one of the key advantages of SunGreen H2's electrolyzers, the lack of degradation even when running an on-off operation. That's what allows us to have this overall system capex saving when utilizing the electrolyzer with intermittent renewable energy and without requiring any batteries in between, or significantly reducing the batteries by up to 90%.
Mm-hmm.
A few are maintained for auxiliary load. Yeah.
Okay, thank you so much, Tulika. I don't think we have any more questions, but thank you so much for your presentation. It was very clear.
Thank you very much.
Okay, now let's move on to the next and last startup for the day. Please, Hanson from Green Cup, the floor is yours.
Hi everyone, allow me to share my screen. Can you see my screen? Sorry, let me reshare again. Okay, so good morning everyone. Hello from Singapore. I'm Hanson from Green Corp. We actually want to do agri-waste revolutions for the sustainable energy solutions. So why we started this route, basically it's because the critical challenges in agricultural waste management in biofuel supply. First, there's a lot of burnings, especially in agricultural waste, especially like 500 million tons are burned annually due to the limited disposal options, emitting a CO2 equivalent of 1 gigaton. Second part is the pollution of the waste burning. It releases a lot of pollutants and causing premature death. The last part, of course, leads to the sustainable energy solutions. The biofuel supply becomes expanding the needs of over 2023-2028, but only meets the 10% of the energy needs. Hence, we'd like to introduce a circular economic model by introducing our waste to fuel as a zero to waste solutions, transforming these waste into values. We're able to reduce the carbon footprint that aligns with the global climate goals. Hence, it comes out a greening of the economic model by balancing a win-win situations for sustainability and also profitability. So what we did is I have a patented technology that convert these plant-based waste, include agricultural waste, agricultural residuals like sugarcane bagasse, anything solid in plant-based structure. Undergoing two steps, which is a pre-treatment, basically is to remove the protective layer, which is lignin, into a soluble form. So what is so special here is we could do it under ambient temperature and pressure within 3 hour times when no inhibition generated. When conventionally, you need the high temperature and pressure, energy expensive. The next step is similar to your beer fermentations, and it could convert into biofuels. Where in this stage, the special thing is we do not need to remove the oxygen and there's no stirring requirement. So the ease of scalability of the processes and the energy savings of the total process is up to 90%. So for more into the process flow, we can see there's a few steps into it, and we're able to convert as the main product here, it's butanol. There's a byproduct like acetone, fertilizer, and lignin. So there's no waste being generated, and hence it considered a closed loop circular that able to helps to transform the plant-based waste into higher value products. So when we see ourselves as the value chain, basically we are in between those producing the agri waste and for downstream regardless on the aviation site or the maritime site. So after we convert it into the biofuel, we enable the productions, then we'll sell it to the marine bunker traders to blend it to the conventional fuels, or we can sell it to the jet fuel traders to process it accordingly. So this value chain, we actually in between both sides, they're actually able to benefit in different industry. Our business model basically is a differentiator as we have our own proprietary biocatalyst with a low energy processes, and it won't cause an inhibitions. Second part is on the scalability. Due to the modular plant system design, it can be deployed rapidly with a lower capex as compared. Lastly, our growth strategy is continue to deepen our ID with the ongoing R&D and drive the recurring revenue via this catalyst supply. So to a close look at what we did in Malaysia as a use case. So palm oil producers, every time they process the fresh fruit bunches, they create a crude palm oil to process to other products. However, currently, the solid part of the plant-based waste, which is the fiber, AFB, and the shells, are recently thrown into the boiler to generate electricity through burning. So we introduced our solution by replacing the boiler part with our solution, generating not only the electricity part with the excess supply of the butanol, we also help them to create a new revenue stream to continue the circular economy. The remaining parts of the waste goes to the fertilizer that helps to go back to the palm tree as a circular economy part. This is some of our journey. We did join some competitions, accelerators, programs before, and reasons that we think it's most important that the process are ISCC certified, which is very important to recognize the carbon footprint reduced, and we are confirmed the process at 83% reduction as compared to conventional fuel processes. So this is our team, combination of R&D, operations experienced, commercial expertise that help us to drive over the process from technology until the actual commercializations. Lastly, let me remind, first part, we're able to come up with this waste to fuel solution that able help us to contribute to the sustainability with low carbon emissions and promote circular economy. We're also able to help you to do a resource efficiencies increment by value additions, consistent on this feedstock supply as compared to those fatty acid, methyl ester used cooking oil. The third part, and also enhance the energy portfolio. Lastly, biofuels can be used in either maritime or aviation. You're able to integrate the current system without major changes and able to do a scalable solutions. So thank you. We hope that this able to create a revolution utilizing the agricultural waste. Thank you.
So much hands-on, very clear as well. I think it's very relevant for the Brazilian market, which is such a huge agribusiness, which has such a huge agribusiness industry. So opening the floor to questions. Maybe a first question would be on, does the quality of the like the sugarcane that you are using, does it matter for you?
No. So basically, as long as it relates to the plant-based structure, we're able to take it. But before we goes to the actual processor, we will size down into certain sizes so that it can enter to the reactors. Yeah.
Okay. All right. Let's wait a few seconds.
Sure.
All right, thank you so much, Hanson, for your presentation. I guess people in the chat or viewing this webinar can send you a message later if they want. Thank you so much.
Thanks.
All right, we are almost at the end of this webinar. Thank you so much for joining. I will now give the word to Anna again from Energy Hub. Anna, please.
Hello, thank you all for your presentations. It was very interesting. It was really a pleasure, a very special moment to hear from you. So anybody that wants to have a contact with the startup that have been presenting today, I ask you to please contact us, and we can arrange this some way the contact between you. Então, agradeço a todos a presença. Eu acho que foi uma oportunidade única, né? Muito especial, de podermos ouvir aqui essas soluções que nos apresentaram aqui as startups de Singapura. Agradeço muito a Singapore Enterprise. Esse é apenas uma amostra do que é possível, né? Fazermos, nos conectando, trazendo essas experiências e soluções. E eu espero que todos tenham gostado muito. E se precisarem desejarem fazer um contato mais aprofundado com alguma dessas startups que se apresentaram hoje, ou perguntar alguma outra coisa a respeito do ecossistema de Singapura, fiquem à vontade, entrem em contato aqui conosco no Energy Hub e a gente facilitará todo esse caminho. Agradeço muitíssimo a Julian, Audrey, so, good night for you in Singapore, and bom dia a todos aqui no Brasil. Até logo.